record button checked. I'd forgotten to turn it on. Okay, so let's go ahead and let me go through this little bit that I want to talk to you about first. And then if y'all have got any questions, we can go back to limits if you need me to, or if there is something on the continuity page as you're working through it this morning, or if you already worked through it and you know you've got questions, then I'll kind of turn it over to you guys and you can ask as you come to them, okay? All right, so for continuity, for a graph or function to be continuous at a point, okay, at a certain value A, and that's going to be an X value, okay, off the horizontal axis. In order for it to be continuous at that point, these three, all three of these have to be true, okay? The first one, f of A, is defined, okay? So let's talk about the conditions as we go through. So what I'm going to do down here is we're going to take a look at a point on this graph that actually is continuous. This one has a discontinuity at x equals -1. I think we all can probably see a huge break in the graph right there. But let's talk about what's happening down at x equals 4. That's this point right here. Okay, so let's talk about what's happening when x is equal to 4. So that first condition was that f of A has to exist, okay? So for that point, f of 4 has to exist. You have to actually have a y value for that x at that point, okay? Just like if I were to plug 4 into the function, if I had the equation, I would get a number out of that, okay? And we do have that here. We do have a point where x is equal to 4 and y is equal to, I'm not exactly sure what, but it looks like maybe about -2.5, okay? So we'll say that's what it is, -2.5. So if you can get a value out of that, whether you know exactly what the number is or not, that means that that point exists, okay? So condition 1 is met for this particular function. All right, condition 2 is that the limit as x approaches A of f of x exists. Okay, so condition 2, limit as x approaches 4 of f of x is equal to. Okay, so let's talk about this. On Tuesday when we talked about limits, or if you watched the lecture video, whichever one, a two-sided limit, which is what this is, exists if the two one-sided limits come into the same point, okay? So let's look at this, and let's come in from the left. Remember, you don't have to go back real far, okay? Come into x equals 4 from the left along the graph, and it looks like my y value is coming into -2.5. Okay, it looks like that, and it actually is true because a part's true right here. It is coming into that point, okay? So as x gets closer and closer and closer to 4, y, or f of x, gets closer and closer to -2.5, okay? That's from the left. Then the limit from the right of f of x, and we already know what's happening here. As we come in from the right, we are also going closer and closer to -2.5, okay? So as x gets close to 4 from the right, y gets close to -2.5. If those two are equal, then the limit as x approaches 4, the two-sided limit, exists and is equal to the same thing, okay? So that checks off the second condition. It's met also. Third condition is that f of A, f of 4 in this case, and the limit as x approaches 4 of f of x, they have to be equal to each other. Okay, that's that last condition. This is the one that ties them together. Okay, this is the one that shows true continuity because the limit exists and it's coming into the same point where the graph exists at x equals this number, which for us is 4 right now, okay? So, and we can check to see that that's true by just looking back at the last two conditions, okay? When a is equal to 4, then negative 2.5 is what we get. When x is approaching 4, the negative 2.5 exists. All right, so we've got the limit as x approaches 4 of f of x is equal to f of 4. They all check, and what that means is that f of x is continuous at x equals 4. Now, continuity can take on a lot of different forms. You can have continuity to point, which is really all we're looking at, okay? You can have continuity everywhere continuous, which is where you look at the function as a whole and you check to see if there are any discontinuities, okay? And if there are, then it's not continuous everywhere, okay? It will still have some point continuity, but it's just not continuous everywhere. And then you also have continuity along the domain. Now, in the first few problems in the lecture video, I don't talk anything about those other two. We're just concentrating on continuity at a certain point. But as we move into the second and then third types of questions that are on the homework, you're still really more looking at a single point, but I talk more about, hey, this is this type of function, so it's everywhere continuous, or this type of function is continuous along its domain, but if you're outside the domain, there are discontinuities, okay? I talk a little bit more about that on those because we're dealing in those types of problems. We are given not the graph, but the actual function, the equation of the line, okay? So it's a little bit easier to look at that and say, okay, well, in this type of function, you have this kind of continuity. And we sort of classify our functions like that because it's a little quicker to deal with a function that you don't have a graph of if you have a good sense of what the domain is, where your problem spots would be with continuity or with the domain, okay? They go hand in hand because what causes problems in the domain are also going to be problems with continuity, okay? All right, so let's come back to this graph for just a second and let's talk about the very obvious discontinuous point there and which one of the conditions that violates, okay? Now, if you look at it and you think about the conditions, one obvious one is that the limit and the function value, they're not in the same place, okay? We have a gap discontinuity, which means that the limit's not going to exist. Okay, so we're not going to have a value for the limit. The two one-sided limits don't equal each other. They come into two completely different y values. And then the point where your function exists at x equals -1 is there where that closed circle is. So f of -1 is 2. The first condition's met because of that, okay? And let me write this down here below. I tell you what, let me just a second flatten out my iPad so I can write a little neater than I did a second ago. So at x equals -1, if we look at the first condition, f of -1 is equal to 2, okay? That's because we have a closed circle right here, and that's at the y value 2, all right? So it meets the first condition. We check that off. And I've already said it doesn't meet the last condition because we know they're not going to be equal to each other. The problem is in MOM, on these first few problems that have the graphs, you have to use the order. You have to check them in order. And the first one that's violated, that's the one you have to mark. Okay. So for this one, we would not mark number 1 because we do have a value at x equals 1. But number 2 says that the two-sided limit has to exist. Well, you can look at this thing and tell that doesn't happen, right? We don't even have to write it down. The limit from the left is coming into 1. The limit from the right is coming into 2. they're not the same number, and so the two-sided limit does not exist. All right, so for this one, the answer is going to be the second condition. Okay, now let me write it down formally, and then I want to talk about the fact that I just called that the second condition. Okay, from the left we come into 1. From the right we come into 2, and that means that the limit from the two sides, the two-sided limit, does not exist because they don't come into the same point. Now, here's the issue. I don't even have to check the third one. Okay, here's the problem with that. That is the second condition, right? That's this one right here. But now on my open math, that may not be the second one listed. These are coded to shuffle the answers. I don't know how to fix that, okay? There is a way to tell it not to shuffle. I have no idea what it is. It's not a box we check. It's in the code of the problem. So I would have to look it up and find how to do that. I have not done that yet, okay? So these problems do shuffle those. If you'll notice right here, they are upside down, okay? The third condition is actually written first, the second condition is written second, and the first condition is written at the bottom, okay? So watch that. You're gonna have to be careful about that on the first few problems because they're all, you have to check them in the correct order, not the order that's in my open math, but the order I just gave you in the notes, okay? You've got to do it that way. I'm sorry it's like that. I wish that I had it fixed where it wouldn't shuffle them, but I don't know how to fix that right now, okay? So just watch it, all right? Now in this particular case, since mine is second, I do check the one that says f of x exists. That's the one that's violated, okay? See the instructions, determine which one of the following rules for continuity is violated at x equals -1. That's what I'm looking for. So the fact that the two-sided limit does not exist, that's the first one of the three conditions that is violated, okay? So that's the one that I choose. So again, be real careful about that. You want to be sure that you use the order written right here. Don't use the order they're listed in the problem, okay? Don't use that order because it will mess you up if you do. Use the order that they're listed right here, okay? And check them in that order. Now you've got a few more like that. You've got one here where there's a hole, discontinuity. So if you'll notice on that one, you can probably tell by looking at it which one is violated on that one. But again, use the order I've given you. Now mine are in the correct order there. Yours may not be, okay, but mine are. Here's another one just like the first one we did, and y'all's is probably a similar discontinuity. The graph won't look the same, but it's probably a similar discontinuity. There's another one with a hole. There's another one with a hole. So just tackle all of those at one time using the lecture video, the first problem that I do in the lecture video. And then your second group down here, it gives you the function and asks if it's continuous at a particular point. So again, you're doing point continuity, okay? Just like the first one, it's just you don't have a graph, okay? And I went through one like each one of these in the lecture video. Your numbers will be different, but your equation forms are the same, okay? So what I do for each one of those will fit yours exactly. They just have different number values, okay? And then the last couple of questions, they're rational functions. With rational functions, and I explained this in the video too, but with rational functions, your problems are going to happen where the denominator is equal to 0. So you start these two problems by setting the denominator equal to 0. In question 9, you won't have to factor, they're already factored. In question 10, you'll get a quadratic in the denominator that should be fairly easy to factor. So you'll factor first. Then you're going to set your factors equal to or not equal to 0. Find out what x would give you 0 in the denominator. And then those are going to be those discontinuities. Okay. It says if there is more than one, which you'll get 2 on both of them. If there's more than one, enter the values as a comma separated list. All right. Now you might happen to get one that's a perfect square trinomial where you only get one value because both factors are the same. That could happen. Okay. If it does, that's all right. Just put the one number in there. But most of you are going to get 2 for both 9 and 10. Okay, they're the exact same type of problem. You do not have to worry about what the numerator is, because even if it would cancel, that's still a hole in the graph. That's still a discontinuity. Okay, and so on both of these, it's not asking for the violation. It's asking for where those discontinuities are. So you're just finding the location. For rational functions, there'll be either a hole in the graph or an asymptote, but either way, it won't make any difference which kind it is. They're both discontinuities, okay? So watch the lecture video, use it to help you get through the problems. These in the middle, instead of having you select the first one that is violated, this one says select all the options below that are true. So if it's continuous, it's going to say no rules are violated. The function is continuous. If it's not continuous, you may have some combination of the other 3 choices. So just watch for that. Like I said, I've done one like every single one of those in the lecture video. So all you got to do is watch how I do it and just follow that same thing. Okay. There's a polynomial function. That's the first one, number 6. There's a radical function that has a root, that's number 7. And then you've got a rational in number 8, okay, that you'll work on there too. All right, do you have any questions? Okay, so what I'm going to do is I will sit here on Zoom and I'll mute myself and stop the video so I can work on something else while you guys are working too. And you can either jump off Zoom and work till you have a question, then pop back on, or if you want to sit here with it on the whole time, that's fine with me too. It doesn't matter to me either way. And when you run into something, let me know and I will help you get through it. Okie doke.